Hi guys, welcome back to the vlogs.
Okay, so inscribed figures. That means we are putting something inside of a circle. We're going to inscribe it into a circle. An inscribed angle in intercept arc theorem. An inscribed angle has a measure of 1/2 of its intercepted arc. So, last time we talked about if this arc, okay, if this angle is a central angle, meaning it meets at the center of the circle, then if this is 27, this is also 27, yes?
Yeah.
Okay, this time, we're talking about an angle that reaches from one side of my circle out to the other. So it's not the central angle, it's not in the center, it's hitting in,
The other side of the circle.
the other side of the circle, yes. Okay, so if it is an inscribed angle, has a measure of 1/2 of its intercepted arc. So if this is 48, what is this angle? If the arc is 48, then the angle is what? 24. It's half of whatever that is, and vice versa. So if I know this is 24, I can prove that's 48. Okay?
Oh, so the angle is half of
The
this.
angle is half of the arc.
Okay.
Okay? The angle is half of the arc. An inscribed angles in same arc theorem. If two inscribed angles intercept the same arc, then the angles are congruent. So do you see there is an angle right here? Yes?
Yeah.
Okay? And then there's an angle right here. Yes? Okay? And they intercept the same arc of AE. Okay? So because those intercept the same arc, this angle D and angle B are congruent, which makes sense because of this rule right here. If this arc that they're intercepting is, 70, then what is the measure of angle D and the measure of angle B? 35, yeah, 35. So they're exactly the same because they're intercepting the same arc. And when I intercept an arc, when an inscribed angle intercepts an arc, it's half of that arc. So if the arc doesn't change, then that means those two angles are going to have to be congruent. So if my angles intercept the same arc, they're congruent to each other. Okay? Which helps me because I got some triangles going on there now. Yes? Yeah. Like, look, I have angle, angle. What type of angles are these? What? Vertical, so they are what? It's the same. So I have angle, angle, and then I have third angles theorem. So I have angle, angle, angle to prove that those are congruent triangles. Welcome to fun. Okay. That's a good question. I don't know why this says okay. Inscribed quadrilateral theorem. A quadrilateral is what?
4.
Something that has 4 sides. Any type of shape that has 4 sides. Okay? So an inscribed quadrilateral, I'm going to put a quadrilateral inside of a circle. A quadrilateral can be inscribed in the circle if and only if its opposite angles are supplementary. So angle B and E are supplementary. What does that mean they add to? Supplementary means
Yeah,
180. So B and E add to 180 and D and A add to 180. I can inscribe it in a circle.
How would you inscribe it in the circle?
Well, because I can draw this, right, this from here to here is what now? What is that?
2 triangles.
It's your what?
2 triangles.
It's your diameter, which means that this right here is how many degrees?
180.
180, which is why angle A and angle D have to add to be 180,
Oh, okay.
okay? And you can do the same thing this way. I can split this. This one's just harder for me to draw because I'm at a weird angle. But if I split it, it's going to split into 180 as well. Okay? But they have to, both sets of separate, of opposite angles have to add to be 180 for that to be a true statement. So if they give you a diagram like that and say, can we inscribe this? and they give you numbers that don't add to 180, you would say, no, not possible, okay? I don't even know how to say that word. What is that? Cyclic? Anyhow. Quadrilateral inscribed angle theorem. Okay? The inscribed angle formed by one diagonal and side of a quadrilateral is congruent to the inscribed angle formed by the other diagonal on the opposite side. So if I draw this diagonal from here to here, okay, and I draw this diagonal from here to here, what it's telling me is this angle right here that I created and this angle that I created right here are congruent to each other. So the measure of angle ABD is congruent to the measure of angle ACD. So if I'm going ABD, look at what I have going on here.
Those are triangles.
Yeah. And ACD, I have another triangle, and I can start to prove things. Triangles are never going away. But this is why we like circles, because then it breaks it down easier for us to solve some stuff. Because with a circle, I have 360 degrees, so I can start to break down angles. Okay. Inscribed right triangle theorem. A side of an inscribed triangle is a diameter if and only if the triangle is a right triangle with its right angle opposite the diameter. Common sense. My right angle always has to be opposite my hypotenuse, so the diameter is the hypotenuse if it's opposite the right angle. That's what it's saying. So JL is the diameter if and only if JKL is a right triangle with the right angle being opposite of JL. It's common sense. You know that. Which then allows me to use some Pythagorean theorem and solve some stuff. Okay? I might add a problem or two to this too. Just so we know. Okay. Arcs and inscribed angles. Okay. If you have an angle on the outside of a circle, it's called a circumscribed angle. Okay? Because the circle is inside of my angle. It's circumscribed. And circumscribed goes with what? We talked about circumscribed before. Perpendicular. Is it perpendicular bisectors? Yes. Which, if I have lines that are tangent to a circle, I can create a perpendicular bisector with the radius, yes? So that makes sense. I have central angles. A central angle is simply an angle that creates an arc, bisects the arc through the center of the circle. And I have inscribed angles where my angle comes and touches the outer edge of my circumference, but it's inside the circle. Sorry. Okay. When I have an inscribed angle, the angle is what compared to the arc? One half. Yes, the angle is one half of the arc. When I have a central angle, the angle is what compared to the arc? When I have a central angle, the angle is the same as the arc. Yep.
Okay, so central is the same.
Central's the same, inscribed is half, which makes sense. Look, this is way wider than this is here.
Yeah, okay.
Okay?
Oh, I understand.
Okay. That we talked about. Let me give you a couple problems and then we'll go from there. We're gonna do this and then I'm gonna do two other problems that I'm gonna draw up. What is YZ? The circumference of the circle C is 8 pi. How do you find the circumference? What's the equation for circumference of a circle? Circumference equals what? Pi times d, or 2 pi r, right? Either way, okay? So you can either write pi times d, or you can write 2 pi r, depending on what they give you, yes? Okay? In this case, I wanna figure out what this is, yes? Okay, and they told me the circumference is 8 pi. So how am I gonna set that up? 8 pi equals what? Am I trying to find the radius or the diameter? The diameter. So which one do you wanna use? Which one's easier? Pi d. So then all I have to do is divide by pi and my diameter equals 8, whatever this is. I don't know what units it is, it doesn't tell us. Okay? So that's what YZ is. Okay? That's all I needed to solve for. Not very hard. So if you know the equation of the circumference, which is pi times d or 2 pi r, that's also on your sheet that you can fill in on this nice little circle sheet. Okay? Either works for circumference. Now let's talk about a couple other problems real quick. Let me draw some up for you. Let's do this one first. Okay. Let's say that I have, and you're gonna pretend that these are all perfect circles. Okay, so let's say I have this circle, and I have this shape and this side of it, actually. Let's do this. I don't know how I got that up there, whatever. Oh, that's not what I want. Okay. So I have this, we're gonna go here like this, we're gonna say from here to here, and we're gonna come down here. I'm gonna say from here to here. And Q, D, A, U. This is 52 degrees, this part of the arc, okay? This part of my arc is 96 degrees. This part of my arc is 112 degrees, and this part of my arc is 100 degrees. Okay. Now, the two inscribed angles, okay, angle, okay, let's talk about this. If I want to figure out what arc QUD is, or UQD, if I want to figure out what arc UQD is, how do I figure that out?
Would you add the two?
Yeah, add these two. So add this and add this, right? What do you get when you add 52 and 96? 148. So that arc is 148 degrees. Okay? Now I want to know, what is the measure of angle A? Yep. What'd you say? Yep, it's 148 divided by 2. Okay? And why did you do 148 divided by 2?
The angle is half of the.
Right, because look, angle A is right here, yes? Which means that it is half of whatever this intercepted arc is. Okay? So if I wanted to figure out what the measure of angle D is, okay, what does D intercept?
D.
Yeah, what's the measure of angle D?
And the base of, no.
It would be half of what? Yeah, half of 152. So what's half of 152?
76.
Okay, because it's half of this part of the arc and this part of the arc that are combined together. Okay, if you want to figure out what the measure of angle U is, What does that correspond with? What does U correspond with?
52 and
No, not 52.
96 and
112.
Yeah, 96 plus 112, and I have to divide that by 2, right?
Mhm.
So 96 and 112
It's
is,
208 and then it'd be 104.
okay, so 104 degrees. Okay, so you see what I'm doing on all of these? Okay, so you're gonna have to look at pictures and be able to do that. You can highlight them and color them, whatever you need to do to figure it out. Okay? But the rule is that whatever arc I intercept, if it's a inscribed angle, it's half of that arc. So it shouldn't be hard. This shouldn't be hard math. Okay? Let me show you another example of something else, and then I will give you time to practice. Okay. Let's say that I have a perfect circle again. And let's say that this goes from this edge to this edge. We're gonna name it A, B. Stupid. We'll just pretend that this is perfect. Okay, A and B. And then this is gonna be here. I'm gonna name this D and C. This is gonna connect here like this. This is gonna connect here like this. And then we're gonna have these diagonals. Okay, and we know that this angle here is 45 degrees. We know that this angle here is 82 degrees. We know that this arc right here is 35 degrees. Okay? I want to know what the measure of arc AB is.
AB.
So I'm trying to figure out this portion here, yes?
Uh-huh.
Okay, what does that portion go with, or how do I
Let's go
solve
with
this?
C.
This is gonna take a few steps. You said it goes with what?
AB goes C.
You think it's equal to angle C? No, angle C is from here to here, right? Okay, so this is angle C, from this part to up there.
Okay.
Okay, okay?
So it'd be angle D.
Wouldn't it be the same degree as the CD? Because it's a circle.
You feel like, no, because look, do you see CD right here?
It's
It's
No,
shorter than
the
this right
arc.
here. Right, the only way that this arc AB is equal to this arc is if this segment here and this segment here are congruent. They're not.
So would we have to find the arc for angle A and all of those too?
Possibly. Let me throw this at you. What angle is intercepting angle arc AB?
What angle?
Yes, name it with 3 letters so that I know what you're talking
ADC.
Not ADC. ADC would be here.
Yeah, so it'd be
No, that would be this whole segment. So it's not ADC.
ADB?
If I do
oh, 'cause you can
ADB,
go
yes, you could go
Oh.
ADB or you could go
C.
ACB. Okay, it doesn't matter, Kayla, you're right. So if I do ADB here, look at what I've created.
A
A
triangle.
right triangle.
Not a right triangle, but a triangle. Now, you know that this whole segment right here is 82 degrees, yes?
Yeah, and that's 45.
And this section is 45, yes?
Mhm.
So then we have to add that one to get 180.
Didn't you just do 180
Right.
minus 45 minus 82?
Oh, why do you want to do 180 minus
To
45
get the
minus
other
82?
angle of the triangle.
Yeah. And then you can times that by 2, and then you get the arc of AB. Yeah,
Are we
that's what I
right?
meant, multiply.
I'm trying to think about what you're
Because
saying.
a triangle has to equal 180. And so.
Yes, a
180
triangle
Let
has
me-
to
let me-
equal
let me
180.
explain this.
I will take
And the
time.
sheet, okay.
Okay,
So
Look
if
into
we're gonna
the
add these two and then put X there.
but you
and-
can't because this section is what's 45, not this whole section.
But,
But this triangle.
yeah.
You mean this triangle right here?
That ain't no triangle.
Oh, so then would it be 45
My bad.
Two?
Well, I don't know, is that a right angle?
Oh my goodness.
I don't know, your triangles are to scale.
Well, I'm telling you, that's because the book even says not to scale.
But it's like, it's
But I know that's 45 and I know that's 82, so what's that little central angle?
Another number.
82 times
Like what? Maybe. Maybe it's the central angle, maybe it's not. Do we know that that's the center point?
Yes, we do.
Does it tell you anywhere that's the center
Yep.
point?
In
No,
my
so you
mind.
can't assume, don't assume. But I can figure out what this
I
angle
knew
is
you
because
were
I can add 45 and 82 and subtract it from
180.
180, which is what? Yeah, but that doesn't give you this angle.
That's fine. 53, by the way.
It's 53?
Yeah.
Okay, so we know that this is 53. Let's see if we can continue to fill some things in from there. Okay, if that's 53 and this is on a straight line here, what is this? What's 180 minus 53?
127.
127. Okay, so I can keep working my way around. This is 53, right?
This is
Because, you know,
120. Vertical angles.
7, yes?
Yes.
Okay,
So that's 53. Couldn't just this.
but I know this now. I don't know what this or this is, right? Is there any way to figure those out?
Well, what? It's the exact same triangle.
I don't think there is a way to figure those out, is there?
No.
So then we have to go to plan B. What's another way to figure out what that arc is?
Find the arcs.
Find the arcs.
Yeah.
Find what arcs?
The arc of A.
Because we're trying to figure out what the measure of arc AB is, right?
Yeah.
Can you figure out what the measure of arc BC is by chance?
Yes.
So if I look here at BC,
It's 45. No, yeah, that's 45, right?
Wouldn't it be half?
No, because BAC.
okay. If I look here at BC, what intersects BC, arc BC?
Angle A.
Angle what?
A.
A.
Angle.
Half angle A, the 45.
Aha, this portion here, the 45, right?
Yes.
So what does that mean BC is?
90.
Okay, I can start to work from there. Okay, now, if you look at arc, I know that's 90, I know that's 35, right?
Mhm.
Okay, I know the whole thing adds to B.
36.
So can I figure out what AD is here?
Yes.
What does it intersect by?
C. Wait, no.
How
B.
about,
B.
Sorry, I'm getting
Angle
confused
B.
by all that's on the
Angle ABD.
okay, and that is how much?
82 times 164.
164. Now look at what I can do. I can say 164 plus 35 plus 90 plus arc AB equals 360. So you said all this together is what?
289.
289?
Yeah.
Yeah.
So
And
then I have
71.
289 plus arc AB
90.
equals 360, which gives me what?
71.
So arc AB is 71 degrees. Okay, so there's different ways of solving this. Because this arc, angle ABD, bisects this arc right here, and that is 82. Double
So
82,
basically what we were trying to do with that
We
triangle.
get 164.
Yeah.
okay?
Stop the vlog.
Yeah, so basically what you were trying to do with the triangle wouldn't work in that case. So
Like,
then we
subscribe,
would've
comment,
done
tweet me
that
at
one.
David Dobrik. Anything else to add, person?
You ugly.
Cake squad.
Okay, let me get your homework.